dapat 2 cos 45 pangkat 4 sama dengan 1/2.
We are going to use the separation of variables method to solve the equation step by step. Let's get started. Step 1. Writing down the problem. We are given this first order differential equation. Now recall that y prime is another way to write dy over dx. So we can rewrite the equation as dy over dx equal to e power of y in bracket 2x minus 4. Our goal is to solve for y in terms of x. To do this, we will use the method of separation of variables. Step 2. Separate the variables. To solve by separation of variables, we need to get all the terms involving y on one side of the equation and all the terms involving x on the other side. So let's divide both by e power of y and multiply both sides by dx. 1 over e power of y dy equal to open bracket 2x minus 4 close bracket dx. Now we have successfully separated the variables. On the left side, we only have terms involving y, and on the right side, we only have terms involving x. Step 3. Integrate both sides. Next, we will integrate both sides of the equation to remove derivatives. Start with the left side. Integrate 1 over e power of y dy. We can rewrite 1 over e power of y as e power of negative y, so the left side becomes integrate e power of negative y dy. Integral of e power negative ey with respect to y is negative e power of negative y. Now let's move on the right side. Integral open bracket 2x minus 4 close bracket dx. The integral of 2x with respect to x is x power of 2, and the integral of negative 4 with respect to x is negative 4x. The right side becomes x power of 2 minus 4x. And don't forget to add the constant of integration c, since this is an indefinite integral. So after integrating, we get e power of negative y equal to x power 2 minus 4x plus c. And last, step 4, simplify and solve for y. Now let's simplify this equation to solve for y. First, we will multiply both sides by negative 1 to get rid of the negative sign on the left side. So it will be e power of negative y equal to negative x power of 2 plus 4x negative 3. To isolate y, we take the natural logarithm of both sides. So it will be negative y equal to ln open bracket negative x power of 2 plus 4x minus c. Then multiply both sides by negative 1 to solve for y. Y equal to ln bracket x power of 2 minus 4x plus c. And that is our solution for y in terms of x. That's all from me.
The question 2 is t du over dt equal to t squared plus 3u, where t is greater than 0 and u equal to 4 when t is 2. Firstly, we have to do a first order linear equation that can be written in the standard form dy over dx plus pxy equal to qx. So what we got here is du over dt minus 3 over tu equal to t, where pt we got negative 3 over t and qt is t. By integrating factor, vt equal to exponent of integration of pt dt. So we just put the answer of pt, that is negative 3 over t, into the vt equation. We got the vt answer, that is 1 over 3 cube. And then we will get the product rule, that is dot product, which is u v prime plus u prime v. And then the answer that we get from the dot product is 1 over t cube du over dt minus 3 over t the power of 4u equal to 1 over t square. From the left hand side, we just take t minus cube u, because when the integration and the differential is combined, there is nothing changed. Besides, we just want to find u. So we have to put t cube to the right hand side, then we can integrate the right side one. So now we got u equal to negative t squared plus t cube c. So next we have to find the value of c by using t is greater than 0 and u equal to 4 when t is 2. So now 4 equal to negative 2 squared plus 2 cube c. And then we got the answer of c, that is 1. And the final answer is u equal to negative t squared plus t cube.
So here the explanation about question 3. By the equation given and satisfy y equal to 0 at x equal to 5, which means we need to find c. So the first step, we just rearrange the equation in terms of dy over dt, and we will get our m and n value. At the left hand side is represent as m, and at the right hand side is represent as n. So the next step is add the next test to our m and n value by we differentiate the both value, and we will get the same value for the m and n. So the next step, we will use equation u equal to integration of m plus ky. So in order to integrate m, we will use let u to t square and plus 1. So we will get our dt equal to du over 2t. And then we will get our new equation, which y integrate of 2t over u du over 2t, which we just put y at the outside because y is just our constants, and we will get the equation y ln t square plus 1. And for the second term integration, minus 2t, we will get negative t square. And then we got our new equation for u, which y ln t square plus 1 minus t square and plus ky. So here we need to differentiate our u in order to get partial derivative of u respect to y, and the answer will be ln t square plus 1 plus ky. So here we substitute the n value with the partial derivative u respect to y, and we will get the k value equal to negative 2y plus c. So the new equation will be y ln t square plus 1 minus t square minus 2y plus c equal to c. At the next step, we just ignore our c at the left hand side because both c is just a constant. And so at y equal to 0 and x equal to 5, we will get our c value. So our c will be negative 25. So after we get our c value, we just rearrange the equation by factorizing y, and we will get our y equal to t square minus 25 over ln t square plus 1 minus 2, which means the answer is proven.
Hi, I'm Maliyanaah. I'm going to explain question 4. So the differential equation is y0 equal to 1 and y prime 0 equal to 0. So first step is change the characteristic equation. So get r2 plus r negative 2 equal to 0, and then factor, and then get r1 equal to 1, r2 equal to negative 2, and then use the formula gx equal to x plus sin to x, and then get the yp prime and yp2 prime, and then use the equation 1, put the substitute c, so get negative 6 multiply negative 3 over 20 negative 2d equal to 1. So solve the equation, and then solve the equation negative 2 ax, get the a equal to negative 1 over 2, and then equation a negative 2b equal to 0, get the b equal to negative 1 over 4.
Thus, y multiple 0 equals to 1, so 1 equals to c1 e square 0 minus c2 e square negative 2 multiple 0 minus 1 divide 2 square 0 minus 1 over root 4 minus 1 over 20 plus 2 multiple 0 minus 3 over 20 sin 2 multiple 0. Next, 1 equals to c1 plus c2 minus 1 over 2 minus 1 over 20. So, for 1 is c1 minus c2 equals to negative 13 over 10. Next, for y prime 0 equals to 0, it is the same as before, just put 0 in x. So, at the last answer, c1 minus c2 equals to 4 over 5. Next step, c1 equals 13 over 10 minus c2. So, 13 over 10 minus c2 minus 2c2 equals to 4 over 5. As the last answer, it will get c2 equals to 1 over 6. Next step, from 1, c1 equals to 13 over 10 minus c2. So, 2 is 13 over 10 minus c2 minus 2c2 equals to 4 over 5. As final, c2 is 1 over 6. Next, substitute c2. c1 plus 1 over 6 equals to 13 over 10. c1 equals to 17 over 15. As a final answer, yx equals to 17 over 15 ex plus 1 over 6 e negative 2x minus 1 over 2x minus 1 over 4 minus 1 over 20 cos 2x minus 3 over 20 sin 2x.
Dengan 82 cos 40